Hi. Thank you for coming. It's an honor to be here, and I'm glad you guys took the time to listen to my talk. Before we start, I have to tell you about my company, so bear with me. We are a tech startup called Manis. We are providing banking services to people who get rejected by the big banks. We are currently at 1.3 million active users, and we were the first ones to introduce Apple Pay in Europe. Now, about the talk. Today we're going to talk about the reactive and reactive system in particular. Some of you may think that reactive is just another buzzword that's going to go away whenever some new technology comes up. But that's not going to happen. Reactive is here to stay. And firstly, it's because it's not a technology even. It's actually a serious modern architectural problem directly tied to modern standards. It's no longer acceptable to have any downtime whatsoever and seconds of response time. So obviously, it's a common problem to be within these standards. So there were a bunch of companies that got together and discussed it, and they put together a document that they call the Reactive Manifesto that basically describes a reactive system that is supposed to satisfy all these requirements. And the topmost goal of this manifesto for a system is to be reactive, meaning that a system must respond to any request in a fast and correct manner. Doesn't matter how high your load is or how many services are down. And they also came to the conclusion that in order to be responsive, you have to be elastic, meaning you have to be able to scale up and down depending on the load. The second requirement there would be resilience, meaning that you gracefully handle failures. For example, if some of your services are down, you don't just crash your view, you say that I disabled these two buttons, though that's temporarily, so that would be a graceful handling. And the last conclusion that they come to is that you have to be message-driven in order to fulfill these two requirements. So we will have a simple MVC application that will have a REST API and a SQL database on the backend. And we will apply, we will fulfill the requirements, and at the end, we will still have the same REST API working the same way. And before we continue, I'll just show you this application first, and then we can modify it a bit. So here's how the REST API looks like. It's a bike rental application. You may know it from I Love Bizer presentations. So we can get bikes. Obviously, right now there are no bikes. We can register a bike, for example, at a particular location. And if we get the current state, that would be, I don't think, it doesn't zoom. Well, anyway, it has three fields, ID, location, and renter. So we registered the bike in Vilnius, but it is available now for renting. So if we rent it to Allard, for example, it says this in plain text that it's rented, and the current state is now that it's in Vilnius and it's rented to Allard. Then we can also return it, and if we return it again, it says an error, of course, and that would be the end result that we return it in Barcelona. Okay. It uses Kotlin, but it's actually supposed to be pretty readable. So we're using JPA for storing the bike. We have three fields, ID, location, and renter. It has three methods, one of them being the constructor, where we register a bike at a certain location, and then we can either rent it or return, and it, of course, checks the sanity checks. Another thing that we're using is Spring Data JPA, the simple one with no custom methods. Then we auto-wire it into our Spring service, Spring component, and basically delegate our operations there. to modify the state inside the database. And also we have a couple of finder methods, defined by ID and all. And this gets outwired into REST controller, so Spring MVC, pretty easy stuff, get mappings and all of that. So we are going to look at this. First of course, we'll start with the bottom one, but we'll also make our application not only message-driven, but also event-driven, because that actually brings a lot more benefits to us. It's important to note that event is not a message, and basically a message, you can think of a message like an abstract type and event as a concrete type. The manifesto says that event can be a payload of a message. So basically you can be message-driven or event-driven or both at the same time. We'll start with the definition, of course. Event is a fact. It is what already happened. It's immutable. For example, if account is closed, you just add another event that it's opened. You cannot delete this event. In order to implement the event-driven architecture, we will use publish subscribe, where we can publish something on an event bus, and subscribers can read this event bus and get updated on stuff. To keep it simple, first we'll simply add this event bus, and post factum, whenever we make some action, we will publish some data structure on it as an event, but we will not have any subscribers for now. Basically, that will not alter any behavior. But since we would have these events available, what if we simply locked all of them? That would already give us great observability, because now event is a part of architecture. It's not like logging where you can forget things. You have to actually think about what data is relevant there and what is not. And that's, of course, the tip of the iceberg, what we can do with these events, which we'll talk about later. So it would be a pretty simple change. I'm not even going to run the application. I'll just show you the Git difference. So first of all, we create these objects. A data class means that every field here will have getter, setter, and will have hash code and toString and equals and all that. So for bike registered event, we're interested in bike ID and location. For rented event, in bike ID and renter and so on. And what we will do, first of all, we will add a magical framework that we're not going to focus about. It's called Axon Framework. That's all you need to know. So basically, we will, apart from bike repo inside the bike service, we will also outwire, that should be visible now, event bus. That is in this framework is called event gateway, but we'll not focus on that also. So when we register a bike, we do the action repo.save, and then we basically add this post factum event to our event bus. Same we do with other actions, and then we add a simple event handler that would route into that method all of the events. Any is like an object in Java, so it will outwire any event and print the toString method of it into info logs. We are not event-driven yet, of course, because we have these events. We will use them later, but they are not currently used by anyone. They don't drive anything, so we are not event-driven. But they are there already. So let's focus a little bit into message-driven. In order to be message-driven, we have to, our application has to communicate exclusively through messaging. Right now, it does it through REST API, which obviously not the thing that we want. So what we can do, we obviously want to preserve our REST API. So we will extract REST API into gateway, and we will translate the incoming parameters into requests, and we'll publish them on request bus. And so we will subscribe to these requests, and so that will become the message-driven approach. I will also show just the git diff to be fast. So all we have to do, First, in REST controller, instead of auto-wiring the service, bike service, we auto-wire request bus, which is called command gateway in the terminology of this framework. It uses completable features, but it's not a concern for us because Spring MVC can handle it. And so instead of sending ID and location separately directly into the service, we wrap these two into an object and send it to request bus, and it has a return value. And we use it for all of our actions, including the finders, because the request bus can return the values. And inside the service, inside the bike service, we have to add this annotation, command handler, that will route register bike request objects into this method. And all we have to do is just simply unpack the variables that we were using previously. And that stands for all of them. So we can say that we are message driven now. That's the biggest part here because it's the base. I have to mention, since we're talking in the context of manifesto, it also highly advises you to structure your API in a way that it's asynchronous, non-blocking, and makes use of back pressure. But that would be off topic for this presentation, and it's described in a document that is similar to manifesto, which is called Reactive Streams Specification. But anyway, since we are message-driven, this leaves us with another benefit, which is called location transparency. What that means is that whenever we want to execute an action, we basically construct an object and we publish it on a request bus. And that request routes itself magically to somewhere and brings us the return value. So the location of the request handler for us is transparent. What you can see in the picture is actually meant to show you the monolith split into microservices. So what we can do is, for example, we can take this request handler, put it and deploy it separately, right? Put it in another jar or whatever, and launch it in a different JVM. And since we are using message-driven in our application, it will actually already work. So that leaves us with component isolation. So there will be a demo which is surprisingly easy to implement, where we will do exactly that. We will use Spring profiles to divide our application into 4 microservices. Let me start them right now. Gateway will have the REST controller. Bike registration service will only have the request handler for registration. And return and rental will have their own request handlers. And we will hit with the same requests to the same port, and we will receive the same result here. Yep. So yeah, I can create a bike, I can get its state, and so on, and it will receive as you can see, rental received bike rent request, and registration received register request. And if I say the get, it will hit all the different services because I put the get handlers into all of them. Rental controller will have the gateway profile. That was bike service before. It had all of the 3 command handlers and also the finder handlers. What we did is we put the finder into not gateway, so that would end up in registration, rental, and the other one. And then we have 3 separate services that have three separate profiles. For example, the registration service has a register profile, and it has register and its own listener. By the way, I have to copy paste these listeners, but that's not a limitation of the framework. It's just you're not supposed to use event listeners for logging. There are interceptors for that. So yeah, I think, yeah, and one more change is that I have to make my H2 database that is in memory by default and recreated by Hibernate by default to be using file and not be created. Because whenever you start an application, it drops everything you have, and with multiple microservices, that's a problem. Yeah. Then next what we do is we revert that commit, because it's good for demo, but you don't just randomly split your stuff. Next topic would be accidental complexity. So we like to use domain-driven design, and we like to split our domains into subdomains so that it reduces complexity in certain parts. We are used to the thing that we have one domain per microservice, but sometimes it actually adds extra complexity, which is there somewhat accidental. And here's the example with the existing applications that we have right now. So if you look at our write operations, you can see that, for example, for registration, we don't have any no validation, right? But if we look for rent or return operations, if you look closely, we basically want to know if the bike is available right now or not. So when we return the bike, if it's already available, that means that it's already returned, right? And separately, when we rent the bike, if it's not available already, then it means it's already returned. So why do we need to concern ourselves with making it more complicated and having two fields instead of one Boolean, for example? And two fields, I mean, we could replace renter and location with like available Boolean flag. And the answer is obvious. Of course, we have our representation, our view, where, for example, a user wants to know location in order to go there and rent the bike, and employee must know who rented which bike. So there is a specific design pattern that can help with that problem, and it's called CQRS, which stands for Command Query Responsibility Segregation. So as you know, any responsibility segregation is good, and it's similar to single responsibility principle in that case. And that's why it actually helps to reduce complexity. So this pattern is based on two definitions, a command and a query. And where a command is supposed to represent write operations, and query is supposed to represent read operations. Just a quick side note that right now, before that, we had a message that could be either a request or an event. Now we split request into two, so message can be either three of these, a command, event, or a query. And they are actually handled differently. For example, whenever you handle a command, you only want to handle it once, right? And you may want to use consistent hashing for that. And whenever you handle an event, you want to send it to all of the listeners because they all want to know the updates. And when you handle the query, you may want to use a simple load balancing. In fact, that's exactly what this Axon framework that I'm using does, and it has first-class support for all these three types. So the first thing what we want to do is we want to split our requests into commands and queries. So for example, rent request becomes rent command, and get bike by ID request becomes get by ID query. But the important part of this pattern is that it does not only apply to requests, it actually applies to everything, meaning that any object that you have in your system will be split into two, one that solely handles the logic and one that solely handles the view. So in that regard, we will split our bike into write model on the left and into read model on the right. And as you can see, the write model has become simpler because it has like 2 fields instead of 3. But that's of course a case, very simple one, but you can imagine how much of an impact that could have, for example, when you have 2 years of development. So it actually introduces a little problem where reading model can be out of sync with writing model. So all commands come to write model and all queries come to read model. But whenever you make a decision in write model, your reading becomes out of date. So you have to somehow notify them. But we got events, so we pretty much covered on that part. And here is how it's supposed to work. So you receive, for example, a rent bike command. You want to rent bike number 1 to alert. And what our write model does, it flips the availability flag to false, so it's not available anymore. Then it can publish bike rented event where it will have the renter name because we can take it from the command. And so the bike queue is able to update the renter. That means whenever we get actual query, the view is able to provide the correct response. So what we will do, first we will split our request bus into 2 buses, command bus and query bus. And then we will split our component into write part and read part. We before had only request bus, which is actually command gateway called in this framework. So we renamed that to command gateway to be consistent with the framework terminology. And we also have a query gateway. And now whenever we receive post, put, or similar, we use command gateway. In this case, it's actually only renaming because we just renamed this class and this variable, but it's actually the same line. What is different is in the get mappings, because right now we use query gateway, which has a little bit different syntax, but it pretty much does the same thing. The difference between command gateway and query gateway is that command gateway uses consistent hashing and query simply load balancing between the available handlers. In the bike service, we simply, there's nothing changed here because we only rename the event bus to event gateway. The change here is that the finder methods are no longer command handlers, they're query handlers. But that doesn't really change anything in terms of behavior. And in the API, we simply renamed our requests to differentiate between commands and queries. So yeah, and the next part would be to split the actual logic into 2 domain models, right? So we just split our requests into commands and queries, and now we will split the actual bike. So here's how bike looked before, right? It was an entity and had 3 fields, and this logic, this business logic, right? Now it looks like this. It has 2 fields. And this is how the business logic looks. It's a tiny bit simpler, but it's a tiny application. What we will do, also one change here in the service is that we remove the finder methods from here because it's a write model, right? It doesn't serve anything apart from commands. So we created a read package where we have a second table called bike view, and this one has all of the 3 fields, but it doesn't have any logic. It has only the getters and setters. Yeah, so look at this. So we have event handlers. We listen to bike register event and save the bike view. Okay, we listen to bike rented event and change the bike with this ID to have this renter. And we do the same with returned, and here we serve the queries. So space-wise, yes, it will have a lot of data, but I don't think it's a problem nowadays. The storage is pretty cheap. But if we're talking about multiple tables, first of all, you don't have to keep this inside one microservice. You can deploy your read model completely separately. You can have a separate Git repository and all of that. You can even, for the important part that I was going to tell later about, but I guess I'll tell it anyway. So, is that you can optimize your write model for writes and read model for reads. So you can have SQL in write because SQL is fast to write, and you can have third normal form and all of that. And you can use MongoDB on your read model, and you can scale it separately. So you can have one instance of write and 100 instances of read model, and you can have 100 different read models. Since you have these events everywhere, you know exactly what happens. So whenever you execute a business transaction, you get like, I don't know, 50 events maybe printed along the way. And so if you crash, you know exactly how many steps you completed. It's actually also really friendly for distributed tracing, like open tracing. It's really easy to configure the interceptors, and you can even see, for example, in Jaeger UI, how you have your requests over there. If you look at this is how tracing looks like. So for example, when we get the register post request, it will cause the register by command to be executed, which will cause handle of this command, which will publish the event. You see registered in Vilnius, which will cause two projections, meaning the two read models to be updated. Yeah, so when you have multiple models, whenever you work on one model, you don't have any redundancies, right? So let's say you have a microservice and BI team wants you to provide some weird GET requests that will lead you to, in very weird ways, compose this big DTO, right? And you have to maintain it. But if you have a specific model for BO, so for BI guys, in their representation, how they see their data, it would be a lot easier for you to implement stuff for them. Two little changes that this framework can give us. First of all, as you can see, I can remove the Spring Data GPA repository from the right side at all. And in order to do that, I have to add this annotation aggregate, which goes from the domain-driven design aggregate. So it is actually a Spring stereotype under the hood. It has a prototype scope, so you can actually auto-wire stuff into it, but we will look at it later. So instead of auto-wiring inside the bike service, instead of auto-wiring the actual repo with Spring Data GPA, we can auto-wire this repository from Axiom Framework Modeling Command Repository. And we can do the same logic here that we did before. It looks a little bit weird, but that's because you're not supposed to use it actually. Here's what I mean. You can remove the service. Now you can put all of your stuff inside the aggregate and put the command handler into constructor. So it will route the register by command directly into here. And in order to publish an event, you have to call this static method, right? And you pass this event right there in a similar way you passed it to event gateway. So you do the same with other command handlers, and now you only have one class for the write part. Now we come to the interesting part, event sourcing. So what if we stored all of our events? Right now we are event driven because we actually listen to our events, and we are message driven. And to see the benefits, we'll simply implement it. And it's very small change. And it's small because all we have to do is make our database not recreate itself. In fact, the Axon framework actually already persists all events into a database. I'll make it into a file so I can look inside the IntelliJ. First of all, I will connect to this database and I clean all of the junk that's there. Then I will launch this application. I will run a couple of commands and we will see what is persisted there. This framework can persist the events into different storages. Because we have Hibernate on the class path, it will actually use the SQL table. So let me run the post. We created a bike, right? Now let me run rent. We rented it to Allard. By the way, here are the events printed. So here is the current state of this bike. It's in Vilnius and it's rented to Allard. So what I'm going to do is I kill my application and the database is supposed to be in the file. So here are the tables that we have. These two are our tables and all of the other tables are created by the framework. Of course, you can put them in a different schema with some XML configuration for Hibernate. But ideally, you're not supposed to use SQL for storing your events anyway. But let's take a look at what has been persisted. So we can see that for the aggregate number 1, 2, 3, 4, the bike, see here you can see that it's a bike. We have an ordered sequence of events. We have two events. First one was the registered event, and the second one was the rented event. I don't think I can zoom it.
That's good enough.
Okay, so here is the payload of these events. So you can see that the registered was this with this location. As you can see, it also has some metadata like a timestamp and something else like trace ID or whatever. So that said, I want to quickly move to the best part. The most exciting part is that as Greg Young, who invented the CQRS pattern, said that most systems require multiple read models to work well. So whenever we receive a command, we do some action in write model and we save it, say, in SQL, we can publish an event, one event, and that one event will be listened by, say, 3 read models, and they will update themselves, and they will be able to have their own storage, whatever they are doing with this data. It may be a BI reporting system, some full-text search engine, NoSQL database, data science systems, and whatever basically you want. The key here is that you put as much information as you think are relevant into your events. Your storage is the event, not the database. Well, right now we use SQL for storing our events, so we cannot get rid of it. There are particular systems that are called event storage. And one of them is called Event Store, which is developed by team of Greg Young. Another one is developed by Axon framework. Well, the company actually called Axonic, but yeah, they have Axon server, which I actually used under the hood when I showed you the location transparency demo, because I launched 4 microservices and I needed some kind of messaging system in between, and so I omitted that for to be more simple, but I actually have a Docker container running on the background with this Axon server, which automatically plugs into this framework and provides all of the routing for commands, queries, events. It also persists all events, and it is heavily optimized for this exact use case of event sourcing and CQRS. So that would be ideal. And the Accent server actually while we're talking about that, let me say, so that would be the open source solution for this multiple microservices thing, where we could use RabbitMQ for messaging and querying, and we could use, for example, MySQL for event store, because we write a lot in there, and we can use Spring Cloud Netflix for service discovery and all that. Or we could use Accent Server, which basically does all of that. And if you're interested in this use case, you can find a presentation from the last year where Alot Beiser, who is the founder and CEO of Accent Framework, does this thing on stage. So Accent Server is a paid, you have to pay money for it. There is an open source version, but it doesn't have clustering and all the stuff you need in production. I think I saw somewhere a tutorial from a guy on YouTube who didn't use Accent Framework, but used pure Java EE and Kafka to implement this event sourcing in CQRS. So yeah, that's totally possible. And this Accent Framework has some third-party integrations like Kafka and RabbitMQ, and I think JGroups and something else. Yeah, so what we want to do is, as we were talking here about multiple projections, read model view projections are synonyms. So we will add another projection, and that would be the coolest part of the presentation. Here's what we will do. In our rental controller, we will add another finder method that will return a history of a bike by ID. And that history will look like this. We create an immutable entity because for every time something happens to a bike, we write an entry with a timestamp and a description. Okay, and it has a generated ID, because the bike ID would be not unique here, because for one bike we would have multiple events with different timestamp and descriptions. So for that we add a Spring Data GPA repository, and we add one method, find all by bike ID. Okay, that would be the list of all what happened to this bike. This is how we will populate it using the same events that we already have. We can also use this timestamp annotation that goes from the Accent framework. And as I showed you before in the SQL table, it has metadata including timestamp. So we will be able to populate one row that bike registered in some location. Okay, and the same for rented and returned, and we have a query handler for this particular read model. We put the old view into the different package, just call it main. And in the API, we add this query, which only has bike ID because we find history by bike ID. Now, when we launch this application, we'll see some magic. So here's the magic. I run the get, and I get the full history of this bike. And we didn't have to make any post request or put requests, because in previous commit, I made our database not recreate itself. So whatever we did in the previous demo, when I rented, I created the bike and rented it to Allard and showed you the SQL table. Now I just add a new event listener, and all the event listeners, they know where they left off in terms of events. So all events are persisted in the database. So we add a new projection that will look into the event store. It will see that it has not read any events, so it will start replaying all of the events from day one. And when you execute a GET request, you already can see your view. So that gives us the replay. It gives us the power of not now, meaning that whenever we want to make a new projection, new report or whatever, we can take our time and not be afraid of losing data while we think about how we go about it, because as it usually goes, before, like until you, like while you are not capturing data that you need for your report, you are losing data. But right now with event storage, we store everything there is to store, so we don't really care if somebody tomorrow comes to us and says, I need a new report. We can be sure that we will be able to provide any report, and from day one. So that is really powerful for analytics and whatever else we want. The Greg Young, who is, as I said, the inventor of CQRS, he wrote a little book which is free. It has about 100 pages on versioning of the events. That's actually a problem, but there are a lot of ways to solve it. So yeah, about this not now that we can wait and stuff. So here's a little bit fitting quote that we can defer some decisions on that, on our architecture. Here's the last thing I want to mention about CQRS, is about cost efficiency in terms of scaling up and down. On the top you can see the current situation on our system. We have a business intelligence system pulling up our data from our events at 4 points of load. There are a little bit of customer that are active, which ends up happening in 1 point of load, and a batch job, which is firing some commands into our system, which has 2 points of load. So before CQRS, on the bottom left, we would have to spin up our microservice up to 4 points in order to be able to handle this BI load. But after CQRS, we can actually deploy 3 different applications. For BI view, we only scale this one up. But for customer-facing app view, since it has a low load, we can even scale it down. And for write model, we have 3 points because 2 goes from the batch job firing commands and 1 from active customers. So in terms of cost efficiency, without CQRS, we have about 4 points more than we would have been if we used it. So with that regard, I would like to mark the elastic, even though it's not like we actually did it. Cloud providers, I think, can now provide auto-scaling out of the box for you, but this CQRS makes it a little bit more cost-effective. That is all on CQRS, and we are moving on. Event is not a side effect, and that is a problem here in our model. If we look at the write model, as you remember, we publish an event post-factum. So in an event-driven, in an event-sourced system, we are supposed to, first publish an event and then add an event sourcing handler that will listen to this event and change the state based on that. So yeah, instead of setting available to false and then publishing an event, we publish an event, and then we have an event sourcing handler, which is a specific kind of event handler that can only be inside an aggregate. So that will lead it to change its state based on the event, and that's pretty much it. Yes. Also, as you can see, we deleted the entity annotation, so we no longer have bike table, we only have bike view table. And that is because every time you start the application, it will read the events from day one and create an in-memory representation and work with that one. There may be problems when you have 2 billion events, but we can store snapshots every 1,000 or so. So yeah, and also about this static method, it will not publish an event unless this event sourcing handler is successful. You can imagine Git without rebase and force push. That is an event source system. Right? If you can take and commit out of context, it doesn't mean anything unless you replay everything from day one. Can you present your logs in court? When we have an event source system, we always know what happened exactly And we can even ensure that on hardware level, so that nothing can be overwritten, for example. With that, I would like to mark resilient, because whenever we have any business, any action, whatever, we persist our state. So if our application goes down, whenever it starts, it replaces all the events and starts from exact point where it left off. So I think it already adds a lot to the resilient part. But of course, you have to handle all of your possible failures and use high availability best practices like replication, isolation, and so on. When we mark all of them, we automatically get upgraded to be responsive. One more thing I want to mention is that there is no more database migrations, because it's important to understand that all of your data is in event store. A bunch of events, that's your data. Anything that's in your databases, that doesn't matter. You can drop your database and recreate it from your events. Like if you have some major change in your schema, you can just drop your database and recreate it, no problem. And you can have old version and new version with separate databases running at the same time, serving requests. What did we get out of all of this? First of all is location transparency. So our application, even if it's one microservice, inside of it talks only through messaging, so you can easily split it and messaging will still be able to reach out to the parts. We have improved modeling in terms of we have gotten rid of accidental complexity, and we can easily reason about the validation. So for example, about the logic. So right now we go about it like, I validated something and then I decided that this happened, meaning that I published the event, and validated, meaning that I processed the command. So I validated something, I decided this happened. And without these events, we say that we can look at the logs and the state of the database, and we see that this changed, and this change means that this happened. So that's a lot of thought process there. Also, we have audit trail. We know exactly what happened. In any case, we can easily pull up our database and solve any disputes. Event store. We can use given when then testing, meaning that given these given these events in the past, when I execute this command, I expect more events. And that's actually how the test module for this framework is built around. You can also use smoke testing. For example, if you store all of your commands and events from the past week, you can replay all of the commands on the current system and see if the events match up or not. Note on the Axiom framework, as you can see, we were able to heavily modify our application while preserving the REST API, and we were able to introduce those things very, very gradually. Right now, we are pretty much at the textbook usage of it, and it's, as I said, literally built for event sourcing at CQRS. It has an open source, it's open source, and it has an active community. You don't necessarily have to use all of its features, though. That's an important thing. Tracing, here are my suggestions. I mostly recommend you to look at the Greg Young's presentation. They really add to this one. And of course, there's a GitHub repo you can reset yourself and try it all. And that's it. Yeah.